Welcome to this explainer. Grab a seat because we're about to dive right into the ultimate cosmic drama. Today, we're literally spilling the tea on how NASA's James Webb Space Telescope almost completely broke our understanding of the universe. I mean, we are talking massive mysteries, wild astronomical plot twists, and a story that literally had the world's top physicists sweating over their equations. So let's just jump right in. Okay, let's start with an absolute mind-bender. Telescopes, they aren't just giant magnifying glasses out in space. They actually act as literal time machines. And here's why. Because light has a cosmic speed limit, it takes time to travel across the vastness of space. So when we capture light from billions of light years away, we aren't seeing those objects as they are right now, today. We're literally watching the universe's baby years. We're seeing the deep past, peering all the way back into the 13.7 billion years of cosmic history. It's just wild to think about.
And to show you just how far back JWST can see, take a look at this. See that little red smudge right there? That is JADS GS Z1140. It's the current record holder for the most distant galaxy ever observed by humanity. JWST is showing us this exact galaxy as it looked less than 300 million years after the Big Bang. To put that into perspective for you, if the entire history of the universe was condensed into a single calendar year, we're looking at something that happened in the very first week of January.
Section 1. Universe Breakers and JWST's Cosmic Shock. Now, looking back this far is exactly where the trouble started. When JWST first turned on and pointed its infrared eyes at the cosmic dawn, it triggered absolute panic in the astrophysics community. Why? Because what we expected to find were tiny, scattered young baby galaxies. The standard model of cosmology says dark matter slowly collapses over hundreds of millions of years, right? But what did JWST actually find? It found a bevy of absolute cosmic bodybuilders. Monstrously massive galaxies, some looking as mature and weighty as our own Milky Way, just sitting right there at the dawn of time.
And you guys, the scientific gossip around this was incredible. Astrophysicist Dr. Erica Nelson, who was part of the team that first spotted these things, honestly summed it up perfectly. She said, "It's bananas. These galaxies should not have had time to form." The whole community started calling these massive early systems universe breakers. They were completely out of bounds, up to 100 times weightier than theoretical models predicted was even possible back then.
So why were physicists so terrified by this? Well, to build galaxies this massive, this incredibly fast, these early galaxies would need to be converting nearly 100% of their available gas into stars. Now, for context, in our normal region of the universe, galaxies convert maybe a maximum of 10% of their gas into stars, because the heat from the young stars pushes the rest of the gas away. So a 100% conversion rate, that is right at the absolute razor edge of what theoretical physics even allows. It basically meant our entire timeline of how the universe evolved might be fundamentally wrong.
But like any really good true crime mystery, the universe was hiding a massive plot twist. Part 2, the little red dot twist, a cosmic illusion.
Enter our prime suspects, little red dots, or LRDs. As astronomers were frantically sifting through JWST's data, they noticed this entirely novel population of high redshift objects. The technical definition says they have a red rest frame optical continuum and a compact point-like morphology. But in plain English, it means they're incredibly distant, really tiny, noticeably red, and unimaginably bright. And the kicker is, they were perfectly mimicking the light signatures of gigantic, mature galaxies. To really wrap our heads around this, we have to look at one very specific prime suspect, Able 2744 QS01. This is your prototypical little red dot, lurking just 700 million years after the Big Bang, and thanks to a phenomenon called gravitational lensing, which is basically where a massive cluster of galaxies in front of it acts like a giant magnifying glass. Astronomers got an incredibly detailed look at it. What they mapped out with JWST literally cracked the whole case wide open.
Section 3. Black holes in disguise. Time to unmask our culprits.
Turns out, these universe breakers weren't oversized galaxies at all. They were actually supermassive black holes wearing a brilliant disguise. What you're seeing here are artist concepts derived straight from the recent discoveries. On one side, we have a red, early universe dwarf galaxy with a rapidly growing black hole at its center. On the other, two supermassive black holes in the middle of merging. The mind-blowing truth is that the intense light JWST was picking up wasn't coming from billions of mature stars. No, it was coming from the incredibly violent environment immediately surrounding supermassive black holes.
So let's break down exactly how this cosmic disguise actually works, step by step. First, you have an ancient black hole just rapidly gorging itself on the surrounding gas in the early universe. Second, as this gas swirls into the black hole at mind-boggling speeds, it generates extreme friction. This friction blasts out massive amounts of heat and intensely bright light. And finally, step 3. Because these objects are just so incredibly far away, this bright point of light bleeds out in our telescope sensors. It totally tricked the telescope into estimating there must be billions of stars there to create that much brightness. It basically made the galaxies look way, way weightier than they truly were.
Which brings us to Section 4. Is physics still broken? Let's get the final verdict.
So after all that panic, all the sensational universe-breaker headlines, here is the verdict from the researchers. First off, we can all breathe a huge sigh of relief. The standard model of cosmology survives. There's no crisis requiring us to throw out decades of physics. Second, we now know for sure that supermassive black holes, hiding out as little red dots, were dramatically inflating the perceived mass of these objects. Subtract the blinding light of the black hole, and the galaxies fit right back into our models. But check out that third point because it is absolutely crucial. Even with the black hole illusion accounted for, JWST is still showing us roughly twice as many massive galaxies as we initially expected. So no, the early universe wasn't breaking the laws of physics, but it absolutely was a hyper-efficient star factory. Because it was so incredibly dense back then, it was much harder for young stars to blow their surrounding gas away, allowing star formation to just happen at this brilliantly rapid pace. Researchers are actually calling this period the cosmic rush hour.
Which really just leaves us here. The James Webb Space Telescope hasn't broken the universe, but it is absolutely forcing us to learn a whole new language to understand its earliest days. We've uncovered these supermassive black holes gorging themselves in the cosmic dawn, completely disguised as massive galaxies. But think about this. If these supermassive black holes were already there, just hundreds of millions of years after the Big Bang, how in the world did they get so big so fast? That is the next great mystery. What else is hiding out there on the cosmic dawn, just waiting for JWST to pull back the curtain? Thanks so much for joining me on this explainer. Keep your eyes on the stars, and I'll catch you next time.